So the next feature to cover is the park. When you get the unit, park will be in a 0 position. So if we hold this button, now if we just press this button for a moment, it'll take us to the park position. But if we hold it down until this light flashes, now it's in a park configuration mode, and it's going to do a sweep of the actuator arm. If we don't intervene, it'll do a full travel and calculate a 1/4 of the total length for the default park position, which would presumably give us some slope for some runoff, but still minimize wind resistance. So I'm just going to go ahead and intervene here and set that as the park position. It gives us a little wag to confirm that, and I'm gonna go ahead and move the motor in now, put it into manual mode, and go clear the park flag. So alright, now let's talk about the wind trigger. So these anemometer here does a analog voltage output. You can see that there. So it says it does a 0.4 to 2 volt range based on the wind speed. So it's got 3 wires on it here. There's a blue, black, kind of a grayish brown. So the brown wires are positive, the black is the negative, and this blue wire is the signal. So takes like a 12 volt power supply for this, so you need a separate power supply. So you take the connect the ground and the blue wire to the input here. So because it's a lot easier for the demo here, I've got this little voltage regulator module. It's got a little display on it. Apparently the flicker rate interacts with the video, gives a little scan effect there. But so I'm going to use this to simulate the signal from the anemometer. Even though it's a little bit higher, this only goes down to 1.2, but it still illustrates the point, and that this unit will work with anything between 0 and 5 volts, and there's a Zener diode to protect over voltage input. So there's a total of 3 ways well, that we can calibrate the wind speed. The first way is based on this onboard potentiometer, which provides a reference voltage, and any time our input voltage exceeds that reference, it'll trigger the park function. So right now I've got this set, if I remember right, to about 3 volts. So I'm going to go ahead and take my little power supply and turn up the voltage. 2.4, 5, 6, 2.9, 3. So as soon as I got over 3 there, triggered the park function. Go ahead and reduce the voltage, and now the unit, the motor without the pulse signal is basically doing like an east return. and I've got the runtime a little bit shortened here for the demo. And then after this east return, the secondary motor will go to its configured park position, since we've got the pulse signal on here. So with the park lights on, our mode light is now off, and it'll stay like this for a half an hour after our voltage has gone down below the threshold from the onboard reference. So it could be a little bit hard to have a proper reference signal to calibrate this with, and a lot of the times something like wind speed is a lot more subjective than a calculated voltage level. So with that in mind, I've come up with some functionality to allow the DarkStar controller to learn the signal level under conditions that you consider appropriate for triggering the park function. So, and basically there's two modes. There's an averaging mode and a peak mode. So using the 9 button here on my remote, I'll press that once. Maybe I need to press it again. There we go. We just can't. I just can't see it apparently by the angle here. So this the rapid flashing of the LED. This is the wind indicator LED. So the rapid flashing indicates we're in a peak mode. So now what I'm going to do is, this only goes on for a minute, so I'm just going to turn the voltage up here. I'm going to turn it up to 2.5. I'm going to turn it back down to 1.2, and a few more seconds here, the light will go off, ending the sample period. So like I would go outside and press the 9 button, so over approximately 60 seconds, the strongest gust that happened during that time would get registered as my park trigger threshold. So you can see the light stopped flashing. It saved that value to EEPROM, and now it's going to use that value rather than the onboard reference signal from that potentiometer. So just to demonstrate that again here, I'm going to put us back into manual mode, and I'm going to jog the actuator arm north, get out of the park position, cleared the park flag on the light there, and now I'm going to turn the voltage back up, and when I reach 2.5 this time, which was my peak, 2.3 nothing's happening, 2.4 nothing's happening, and right as I got 2.5 there, so there's the park trigger. And so as before, it's kind of going to do an east return function here with this motor, and then go to the park position on the second motor. All right. So now I'll demonstrate the averaging mode. So first, let me get back in manual control once again. Just going to move it a little bit, and now I'm going to press the button, the 9 button, once. We get the rapid flashing as before, and I'm going to press it a second time, and now it starts flashing slowly. So now it's in the slow, indicates the averaging mode. If for some reason I wanted to abort, I can press it a third time, it flashes a few times, it's out. Whatever it was configured for before is still in effect. So I'm going to press it here. Okay, so now we're in the we got the peak mode on. Press it again, and now it's flashing slow. So now this is the average. I'm going to speed averaging. So I'm just going to leave it at my reference signal here at 1.2 for a little while, and turn it up. I'll go ahead and turn it up to 3 volts, 3.2 volts here for a little while. And take it back down. Maybe 2 volts for a little bit. Drop it back down. So a few more seconds here. So there, that flashed and stopped. So the average over that period now is the threshold. So I can find out what that is by doing a little sweep up again here. 1.92. There, got 2.1 volts. Is the average of what I had during that period, and so that's what's triggered the park function now. So in the event that I wanted to get back to using the onboard reference signal instead of one of these learn speeds, that's what the 10 button is used for, and that clears the learned value and sets it back to the onboard reference signal. So who knows, maybe we'll come up with some more features for buttons 11 and 12 if anybody has some great suggestions. So but that covers it for now. That's the new DarkStar dual axis radio controlled tracking controller with the remote sensor. And thanks for watching our video, and stay tuned for more.